So who is the audience for this class? Primarily GINT users, those who use GINT in companies with multiple offices across different geographies. We had companies that use GINT in multiple offices across the state, across the country, and across different continents. Then GINT administrators and GINT managers, those folks who manage GINT at their companies, and to a certain extent, IT departments, folks who manage enterprise databases at their companies, since we are focusing on GINT Professional Plus in this class, and GINT Professional Plus as a back-end uses enterprise database. There is a very few enterprise databases, if any, that are not managed by IT departments. So let's quickly review how subsurface data is managed these days. So it's still mostly on a paper, Excel, or CAD. It's still standard practice to go in the field with a paper log and record with a pen everything observed in the field. But more and more often, people tend to copy this information into Excel, Microsoft Word, or even draft it in some CAD environment, for example MicroStation. As you know, GINT on the other hand uses database, and in GINT a raw data is entered. So what is the big picture? So the general idea is to migrate all the paper documents into enterprise database where data can be searched, filtered and queried easily and retrieved on the map, which is more natural environment for engineers to look for data for rather than different drawers, boxes or various digital files scattered all over the network. So what is to manage in GINT? So let me draw a parallel between CAD standards and GINT standards. Since most folks are familiar with the CAD standards, please consider that a loose analogy. So in GINT, we have system properties by which we basically manage project, interface, and user preferences. That would roughly correspond with the workspaces in MicroStation, like users, project, interface, and user preferences. Then in GINT, we have data templates, as opposed to seed files in MicroStation. And while seed files are drawings or drawing templates, data templates in GINT are databases. Then we have report templates in GINT, which is rough equivalent to sheet models. So GINT reports in CAD terminology are created in paper space or sheet models. And then in GINT we have symbol libraries, in which we create, store and manage symbols of different kinds, like stratigraphy or lithology symbols, well symbols, sample symbols, and many others. This could be equivalent to cell libraries in MicroStation. And then in GINT we can have reference files, images, photos, PDFs, and so forth, which may be considered as a rough equivalent to references in MicroStation as attached DGNs or images. Then we have GINT rules, which is GINT's application programming interface, which is close equivalent to MicroStation VBA macros. And then very loosely we could compare GIGL, Geotechnical Integrator Graphical Language, with MDL, MicroStation Development Language. Let's see what else is to manage in GINT Pro Plus. Again, we are focusing here on GINT Professional Plus with a back-end enterprise database. So let's observe GINT management or GINT administration. And who manages it? GINT standards are most commonly managed by GINT manager or administrator. It's a domain specialist. It's geotechnical, geoenvironmental engineer, or maybe engineering geologists. And then we have enterprise database. That's again like always in the domain of the IT departments. So that's database administrators. Then we have network. So if you have multiple offices across different geographies that hit the same central subsurface database managed by GINT, then network setup is very important to be aware of, such as bandwidth, quantity of data being pushed back and forth, user rights, and so on. And then optionally, virtual or cloud environments, again managed by IT departments, either internal or external. So in the case of virtualization, quite a few companies virtualized their environments in-house, but as more and more companies are moving to cloud, that's usually outsourced to third party. GINT Pro Plus with Enterprise Database as a backend gets geotechnical department on IT's radar. GINT Logs and GINT Professional are relatively simple software applications and traditionally installed by GINT users. GINT Pro Plus, however, will involve IT department, especially on the enterprise database part, network part, and optionally virtualization or cloud environment. So the virtualization and the cloud computing became buzzwords in the last couple of years, perhaps for the reason. So let's consider GINT in this kind of context. We will consider a couple of scenarios, and we will start with the scenario 1, in which basically GINT's back-end database, enterprise database, lives in the cloud. It's installed in the cloud and managed in the cloud entirely, while GINT client lives someplace else. One good example of cloud computing is Amazon Elastic Compute Cloud, or Amazon EC2. And Amazon EC2 presents a true virtual computing environment, allowing you to use web services interfaces to launch virtual servers, known as Amazon EC2 instances, with a variety of operating systems, load them with your custom application environment, GINT for example, or SQL Server for example, manage your network access permissions, and run your image using as many or few systems as you desire. Amazon EC2 provides resizable compute capacity in the cloud. What that means basically is that Amazon EC2 changes the economies of computing by allowing you to pay only for the resources or the capacity that you actually consume. Like for example, instance hours or data transfer. In case of GINT, that would mean like, okay, how many hours did I use GINT or database saved in the cloud, or how much data did I push back and forth from or in the cloud. So just for your information, there is several locations, physical locations of Amazon EC2 globally, and they are presented in yellow color here. You can see North California, Virginia in United States, and I think recently they added one in Washington State, Seattle, I believe. And then in Europe we have Ireland, and then in Asia, Singapore and Tokyo. There is entire recording about GINT and Amazon EC2. If you're interested in details, we can provide you a link to it so we can review it. And the second scenario is running both GINT client and enterprise database in the cloud. That can also be done with Amazon EC2 as described before, or alternatively there are other virtual environments that some of our clients use, and one such environment is Citrix. Here is a real-world example of one of our clients. He gave us permission to show this graph and some of their data without mentioning the names. So they have 90 offices that they run GINT in, over 230 GINT users, and they have entire setup in Citrix environment. In a way, they outsourced their IT or part of their IT. And this pyramid shows the GINT change request and GINT support request. And since there is a lot of offices involved and a lot of users, obviously the support and change request structure reflects that complexity. So first at the bottom we have GINT users, then we have corporate help desk, then system administrator, then regional support, then network administrator, then Bentley support they call for, and then GINT standards committee who defines GINT standard database, reports, symbology, and everything that's to manage in GINT, as mentioned in the slides in the beginning of this presentation. And then they have a system owner who controls entire support and change request structure. So this is one of the most complex setups that GINT is run in. Another advantage of running GINT in enterprise environment, especially if you're a Bentley client in broader term other than GINT, then you can take advantage of GINT integration and interoperability with other Bentley software, enterprise-wise. And we will demonstrate few examples of it. Most commonly that would be civil engineers on a road design or a land development, or GIS folks at the company that they want to expose data on the map available to everyone across the company, or generic CAD environment like MicroStation and so on. So let's observe just a few examples of it. So another very useful interoperability is GINT and ProjectWise. So GINT can store references or paths of images or photos taken in the fields, or PDFs that can be scanned, legacy reports, logs, and other reports as well. And all these files can be referenced in GINT and stored in ProjectWise. Traditionally, those files were stored someplace on the network, and now it can be stored in a ProjectWise. That gives us much greater flexibility in collaboration, file, and content management. Another important thing about GINT and ProjectWise is that now we can store a master GINT library in the ProjectWise, and most of GINT users know the importance of the library. So this option makes GINT managers or GINT administrators life much easier, so they can actually centrally manage their master library and not lock it. With GINT Select Series 1, we introduced iModel publishing to produce 3D cylinders, and I would encourage you to visit Bentley's GINT eSeminar page and view 3D visualization of GINT subsurface data in MicroStation, in which you can find steps required to create 3D meshes and solid models in MicroStation based on GINT raw data. Another very interesting integration and interoperability is GINT with civil products like InRoads, Geopack, and MX Roads. So there are in GINT utilities in place in which we can exchange alignments and surface data, DTMs or TINs, via LandXML. And Geopack in particular has an additional geotechnical set of tools that enables easy migration of subsurface data from GINT into Geopack. So geotechnical data can be shown on sitemaps, on profiles, and sections as well. Finally, there is always a need for integration of GINT and ArcGIS because ArcGIS is widely used in many companies. So we developed GINT for ArcGIS add-in, which is in essence toolbar that runs within ArcGIS and establishes a live connection to a GINT database in the background. And in this scenario, GINT is used as a server to ArcGIS, so it not only serves the data to ArcGIS but also serves functionality, meaning that you can call many GINT functions from within ArcGIS.